Page 26 is pretty straightforward. It has a lot to do with slopes. I just want to talk about a few reminders regarding slope, and then I'm going to show you another trick on your calculator that can come in pretty handy. Another word for slope is rate of change, which you'll hear a lot more as we continue in mathematics. It's easy to think about even the Troisi triangle. So remember, we have our Troisi triangle here with distance, rate, and time. Often on a graph, you'll see distance on the vertical axis and time on the horizontal axis. We could plot these 2 points, 1, 1, and 3, 4. So this could mean that at 1 hour, we were 1 mile away from home, and then again at 3 hours, we were 4 miles away from home. Finding the slope of this is really just finding the rate of change. In this example that we use often, that's simply the speed. We're talking about distance and time. The rate of change, this rate is the velocity or the speed, and simply finding the slope should work. Again, Troisi triangle wise, if you cover up the rate, you can see that the rate should equal the distance divided by the time. Well, when we find the slope of this, when you take the distance divided by the time, that's what we are finding. Because the change in y, right, this here is the change in y, in this case would be 4 minus 1, or 3. And the change in x on this side is simply 3 minus 1, or 2. So in our example, the slope connecting these 2 points is going to be the change in y divided by the change in x, or 3 over 2. But if you think about it, that slope is simply the rate of change of the distance with respect to time, aka the speed. You're probably used to the formula where m, the letter we typically use for slope, is simply the change in y divided by the change in x. You may not have seen this notation that I'm starting to use. It's just a triangle, but it's actually a Greek delta, and in mathematics that represents change in. So it's just an easier way. We get tired of writing the whole change in thing all the time. So delta y divided by delta x means the same. You may have remembered from last year, sometimes you'll call it y2 minus y1 divided by x2 minus x1, where again, this isn't, that's not y squared, that's not y times 2, that is simply a notation for the 2 different points, where x1, y1 is 1 point, and x sub 2, y sub 2 is the other point, but we're still doing the exact same thing. y2 minus y1 is the change in y. x2 minus x1 is the change in x. Final thing I want to talk about for page 26. Again, hopefully review for many of you, but if not, it's a nice little reminder. And it's simply finding intersections on your calculator. We've done a couple problems like this, but they're important enough to review again. Let's say I'm figuring out what to do with my cell phone plan. There's one plan where I have to pay 10 cents for any text that I send. The alternative plans, I can just pay $15 for the entire month and get unlimited texts. So if you think about this, we can turn this into algebra. For plan A, that means the total cost of plan A is simply 0.1, if we're doing it in dollars. 0.1 would obviously be 10 cents. 10 cents times the number of texts is how much I would pay for text under that plan. The alternative plan, I messed that up. This should obviously say 15 because my cost is $15 per month for unlimited texts. So this just says I pay $15, but notice it's not a function of t, right? There's no texts in here, because if I send no texts, I pay $15. If I send 12 texts, I pay $15. If I send 3 billion texts, I will still only pay $15. So these are the 2 possible plans, and obviously what you need to figure out is, should I go for plan A or should I go for plan B? And I'm sure you already figured out, it depends, and it depends on how many texts I would send in a particular month. Well, one thing you can do here is to solve this system of equations which in our simple example is pretty easy. We'll do that. We'll do that real quick just to show. To set the costs equal, I simply need to set 0.1 times t equal to 15. T obviously standing for texts here. If I solve this for t, 15 divided by 0.1, if you want to think about it, 0.1 is the same as 1/10. That's also 15 divided by 1/10, but dividing by a fraction is the same as multiplying by the reciprocal. So this is just 15 times 10 over 1, or 150. So this quickly tells us that if I send 150 texts, it doesn't matter. I'll pay the same with A or B. And clearly, if I'm going to send more text than that, it probably makes sense to you that I would go with plan B, where I don't pay for those extra texts. But if I'm only going to make 3 texts, then clearly plan A would be better. That would only cost me 30 cents instead of paying the $15. That's a pretty easy system of equations, but a lot of times it's nicer just to use our calculator, because if we can graph these and find the intersection, that also tells us the point where they would intersect. So turn on your calculator, pull it out, a little practice here. I want to highlight the screen for you. So in y1, I'm going to make my first equation, which is simply going to be 0.1 times x. X just representing whatever variable. We're using the variable texts, but x stands for that. That will show me the cost if I pay 10 cents per text. The other one, notice it's not a function of x at all, but I can still write that equation, because in this case the equation is just 15, the cost is 15, but that will give me a horizontal line at 15, which is exactly what I need. Now when I think about my window, this is going to be the number of texts, so maybe 0 to 400 would be pretty good. The y is my total cost, 0 to 100, hopefully pretty high, especially since the one cost is 15, so let's say maybe 0 to 25. Now I should get a nice looking graph. We'll graph this up. Looks pretty good. So you can see clearly this horizontal line is plan B, where I pay $15 no matter what. And this slanted line, obviously the slant with a slope of 0.1, shows me paying no fixed cost down here. I pay nothing. But then for each text that I send, it's going to cost me 10 cents. I can use my calculator to find that intersection. To follow along closely, I go second trace, which is the calc feature. Do second calc and the whole little menu here. Obviously the intersect is probably what we want. So you can scroll down or just hit 5. Now the calculator is going to ask you for a first curve. And remember, that's because you could have 5, 6, 7 different lines on here. So the calculator needs to know which ones you want to know the intersection for. In this case, we only have 2 lines, so it's kind of easy. You hit enter for the first line. Notice how the cursor is now on the other line, which is the only other option. So you hit enter again. Now you told it, I want to find the intersection of these 2 lines. It's going to ask for a guess, because it's going to do lots of little calculations to find that intersection. You can move the cursor closer to the intersection. That will technically make the calculator's job a little easier, and it'll go a little faster, but it's so fast that you probably won't notice the difference anyway. So just press enter, and notice it'll take you right to the intersection, which is what we anticipated. If you make 150 texts, you'll pay $15 in either case. And clearly we know, therefore, if I'm going to do 200 texts over here, I should go with the fixed rate plan of $15 per month. If I'm not going to send many texts, the 10 cent per text plan would be much better. So great little thing to do with the calculator. You'll do this a lot over the next 4 to 10 years. So practice if you need to, and I will see you tomorrow.